devices, and we've got an hour and 45 minutes roughly. Do we need to revisit anything else in the agenda, or do we can spend about 45 minutes right now on, I can do an IAO presentation. I'll just steal one from the internet. Day, so that's cool. Let me just make sure this is. He dives a little deep, or a little. All right. 45 minutes on IAO, or too much?
This will get us to understand what we're doing by adding a driver.
Once you've got a driver loaded for these devices, this tells you how to use that driver. And because the problem, the librobot control is fantastic, but librobot control covers what's built in, right? It doesn't cover all this stuff that's you have to add on, right? So we're focusing on the librobot control API for like driving the DC motors and using the RCPY stuff for driving the DC motors. Great. When you start wanting to add stuff on, this is really the only way to go. And even for some stuff that's built in, like in my view, the IMU, if you want to start taking better control of that, just loading the IMU driver might be a good way to go as well. All right. IAO has all the weird sensors. All the physically I/O stuff. It started out as more industrial I/O, like really heavy industrial, but now all the lightweight stuff. If it's an A to D, D to A, physical world interface, most of that's landing in IAO. So there's some kind of random generic devices, but also more specific devices that are going to be in there. There's the other subsystem. He's just mentioning this. There could be a couple other places where things like a temperature sensor might show up that are used to like measure the temperature on your motherboard. That's HWMON, right? Those are HWMON are largely drivers for monitoring the system itself. But this is IAO stuff that's more outwardly facing. You'll also find some things in input, like keyboards and mice, like things that are meant for human input. Won't necessarily show up in IAO because they're meant for human interactions, but even things that might be interpreted that way are more and more likely landing in IAO now moving forward, unless it really is just a keyboard. High-speed sensors, triggered sampling. It gives you mechanisms for essentially doing monitoring and so that your application doesn't have to be bothered with a lot of extraneous data. There's ways that you can essentially filter that off using the driver, so that you get notified on events.
Why do we need to divide the classification between IIO and other kinds of sensors? Why can't they just all be?
Why can't they all be IIO?
Well, so I go to drivers in the kernel, and then I can see. I don't know what else to see. It seems like all the sensors we deal with.
Yes, they'll all be in IIO. Unless your gamepad, not IAO. There's a driver for your gamepad.
That's like, the gamepad to me is a dozen sensors.
And it all translates into keyboard button presses. It's human input. It goes through a totally different subsystem. Not totally. It doesn't use IAO. So it is an input device, but it's not using IO. You're not interested in the individual sensors as sensor data.
Correct.
You're interested in keyboard presses.
Okay, so it's already gathering data from sensors, packaging that into a certain format, and then delivering a standardized format. So it might have its own industrial standard. Is that? And these are more raw information, almost.
Raw but categorized, right? So that you still know that you can put it in a categorization of some kind, which helps you kind of smartly use it, but not the same as like just interpreted into a keyboard press or a like specific human interaction to the computer, right? It's something that you're going to now be interpreting in some way in order to come up with something. So things like this: accelerometers, gyroscopes, magnetometers, IMUs, temperature sensors, barometric pressure, humidity, ADCs, ambient light, gesture sensors would still kind of go in here. Different chemical sensors, health sensors, and sensor hubs. So you're kind of built up of channels of data, triggers. That either the hardware has support for triggers that kind of like because what you're trying to do with triggers is you're trying to avoid wasting a ton of your CPU time looking for something, looking for some sort of event. So you can filter it out with triggers. Some you can push down into the kernel, so it will provide triggers for you. Some hardware has triggering mechanisms, so you can say, okay, only do something when the device don't tell me the accelerometer data if it's not moving. Right? But if it starts to shake, notify me. Right? A lot of accelerometer hardware has that capability in it. I don't need to spend more time on like why this or why that. We're always going to use it. There's a library that allows you to communicate with these devices in your application a little bit more intelligently. I would say for most of this stuff, we're just fine with the sysfs file interfaces. It really gives you, if all you're just looking for is being able to grab the latest data samples, that's good enough. But there are ways you can break these things out into data structures and use that to define, to get it to make your application more intelligent, right, about how it interacts with it, and faster. So let's get into the, this is, so you can set the triggers with sysfs entries. If you need some high performance stuff, are you doing any high throughput stuff? So you really don't need buffers, but there's ways that you can get buffers and time stamping, because a lot of the IIO stuff is for like more significant data logging, right? So single shot reading, this is what you're going to be doing most of the time. You go to the device, right? You're reading the temperature, ambient temperature, reading the scale. So there's, for each individual class, it has a unit in general. So like temperatures are in millicelsius. Okay. So in order to
so you're saying that if I look up a sensor and it claims a category in IIO, then it's going to output data that conforms to one of these standards?
Yes.
And where's the lookup table for?
I don't know yet. For what the data format is, I'm hoping he covers that in here.
Yeah. I had no idea.
So for temperature, it's millicelsius. I know that there's in the documentation, in the kernel documentation, there's some of that information. And in terms of, because I mentioned that the ABI, the sysfs ABI, so some of the descriptions of those files for the different sensors are documented there in the kernel. but I'm gonna see if he did a nice summary. Don't worry about events. Consumer channels, data processing. There are some handy utilities. See if any of those are installed. No. I think some of these utilities are probably pretty handy to So there are some utilities to kind of look up what, to do a little bit more intelligent parsing on what I/O channels are out there. We'll install one to kind of get a look at it. It gives you this type of output, right? You see a maximum thermocouple with these channels, right? You see this looks like to be some sort of environmental air quality sensor, right? So you've got the CO2 concentrations and the VOC, that's a particulate, I think, I'm not sure.
No, it's not particulate, it's volatile organic compound.
Oh, okay. So this is still an air quality sensor, right?
Mm-hmm.
Okay, but, so yeah. So buffer data capture, we're not doing buffer data capture, so let's forget that. But there's ways to grab whole buffers instead of. Hey, look, they did their demo on a Beaglebone. Not surprising. With an oximeter. Alright, so capturing data, and that's what that looks like. That's just his fun little hacks. There you go. This is the. Here's his link to the documentation, which is pretty much where I've been pointing you back to. So proximity. We're looking at magnetometer.
I really want to know about this angular position sensor.
Oh, okay. Yeah, I don't know if that one has a driver though, so we'll
Did we already check?
that's the AS device, isn't it?
Yeah. Wasn't there?
We haven't found it yet. I haven't been able to ask the
that's
question.
What you sent that on the, okay,
got it. 2 weeks noobs have been locked out of the web interface apparently. So I have a task tonight. So looks like magnetic field along axes X, Y, and Z. Data converted by application of offset, then scale to Gauss. So this multiplied by the scale factor gives you Gauss.
But there shouldn't be like 30 Gauss. Oh, maybe there should. Maybe the other sensor was giving us milligauss. Yeah, so 300.
I did a little dashboard I'll show you here in a little bit.
Okay, so
You can kind of watch. I've got a compass view of the magnetometer that's on here that you can kind of see how bad it's working or how good it's working. You can probably clean it up a fair bit.
magnetic field levels around homes.pdf. CSD.
For known device offset added to prior to scaling with scale. So I think always you have to it's left up to you to convert raw into units by multiplying by scale. So we should really always be multiplying by scale.
This is a really neat PDF.
So I spent 15 minutes on that. Do we need to go any more detail on IAO? I'm going to go ahead and install this LSIAO because I think it's interesting.